Cool. Hey everyone. Welcome to the last day of the Fologram Digital Futures workshop. Thanks for tuning in the last couple of days. So just obviously, like I kind of usually start the day on a few housekeeping things. It'd be good if you guys could just go to this this community forum post and download the sculpting file template. Also, the other thing you'll need to download is the Chromodoris plugin for Grasshopper, so you probably won't have that installed. You can jump onto foodforrhino.com, which if you've used Grasshopper before, you'd know a lot about, and you should be able to just download this file. So I mean, I'll demonstrate it myself, just how to install it if you don't know how to. Hola Alexis. So just log in and click download. It's really easy to make an account if you haven't already, and then you can, open up that folder in your download section. I'll just get it up. So it'll look something like this. And the two files that you need are this Chromodoris file and this KD tree DLL file. So we need this plugin specifically because we're going to simulate a carving technique with the Fologram application today, and because we're obviously all working remotely, we can't do any physical carving, so what we're going to do is use an application that kind of does some digital carving for us so we can simulate the technique a little bit, and Chromodoris is an isosurfacing plugin that's going to be really helpful for us to be able to do that, just to give you kind of an idea of what it would be like to physically carve an object with Fologram. So copy those two files, and then what you want to do is inside of Rhino or Grasshopper, you go to File, Special Folders, and then just go to the Components folder. And this is where basically, oops, it didn't come up for me, Special Folders, Components folder. This is basically where all of your plugins live. Just inside of there, and you want to paste those guys into this folder. So I've already got Chromodoris and the kdtree.dll. So if you could all go and just download those quickly, that would be great as well. So I just want to isolate that straight away. We're going to use it probably in about 20 minutes to half an hour or so. So just give you a bit of time to go and install that plugin really quickly. You'll have to restart Rhino and Grasshopper as well to get it working. So just make sure that you go ahead to foodforrhino.com, download the Chromodoris plugin, and then inside of the components folder on your computer where your Grasshopper file or plugin files live, just paste that data inside of there as well. One other thing just to double check, if you're kind of new to this, right click on the file and just go to properties and make sure that the file is not blocked. Sometimes when you download these files, they can actually be blocked by your computer, and you'll get a little unblock button about where my cursor is right now. So I'm not seeing it because mine's unblocked obviously, but just make sure it's unblocked as well when you're going through that process. Cool. So one last thing I just want to quickly mention as well. It's a little thing I asked for yesterday. On the same forum post, I've posted these Fologram markers, and I did ask everyone to print the first page off for today's session, because we're going to be using these markers to track geometry from our devices. Using the track markers component, which is a really powerful tool in Fologram. It kind of enables you to augment tools for fabrication purposes, and we're going to use it to simulate how you would actually do the sculpting technique in a real life situation. So print that guy off, and if you could just cut out, if you've got some scissors handy, just number 0 or just any one of them. It doesn't really matter too much, but it'd be great if you could just quickly print that out, just the first page. You don't need all 9 pages, just page 1, and just cut out one of these Aruco markers so you can fully engage with the tracking part of this session. Cool. So today we're going to be focusing on how to augment physical tools with holographic information to assist with this sculpting fabrication technique. So we're, like I said, going to be looking at one particular tracking component that we haven't quite covered yet, which is the track markers component. So I'll be running the first half of today's session in a similar way to the previous sessions we've had. So it's a little bit more of a seminar, I guess. And then in the second half of this session, in about an hour and a half from now, we're all going to jump onto to Zoom to discuss some of the designs and ideas that you guys have uploaded to at.studio. So I've seen a few models come in. If you haven't uploaded a model, I highly recommend you do so, before we jump onto that Zoom call. I think it's going to be a little bit of a requirement for you to get the participation certificate for this course from Digital Futures to upload something to at.studio. So if you can't even get it done today, then at least by tomorrow we'd like to see some models up there. And then we're going to jump on the Zoom chat and we'll all have like a more holistic discussion about what's on at.studio. So right now we've got a few different models coming through. It'd be good to see a few more. So these models, obviously, we were asking in particular to look at a fabrication idea for the timber fabrication field simulation that we were doing previously. It'd be great if you could upload yours. We're also interested if you've been playing around with some of the other applications that we've gone through in the last few days, if you could upload some work in progress or some progress from that as well. So make sure you've got your at.studio models uploaded in time for the Zoom call in about an hour and a half from now as well. Like I said, to get the participation certificate for Digital Futures, it'll be just a requirement to have something on that forum. Cool. So I'd like you all to firstly just open up a Rhino and Grasshopper file. So I'm working in millimeters today. Make sure you're working in millimeters too if you can. That would be great. And just get a blank document of both of those up now. Yesterday, obviously, we covered a few different tracking components. I think we looked at track pointers, track the device, track the environment, track the scan. There's one in particular that we didn't look at that I was just talking about, which is the track markers component. So we're going to begin by taking a look at this firstly today. So hopefully you've printed out and cut out one of your Ruko markers. So I'll show you like my sheet there. I've kind of gone and cut out one of those markers specifically for this session as well, and I'm going to use that one to demonstrate what we're going to do. So the track markers component, if you just go up to the Fologram tab in Grasshopper and under tracking, it's this one here that looks like it's got a little purple QR code sitting there. I'm just going to drop that onto my Grasshopper canvas. So the track markers component can track 3 different types of markers. So those markers are the Ruko markers that we're looking at today, and it also can track little QR code markers, but it can also track a thing called an Ruko cube marker, which is almost just like 6 Ruko markers kind of stacked onto one another. And I'll just show you on my desk what each of these things kind of look like. So here we have one of the Ruko markers. We've got them on our business cards, so it's easy for us to use them in fabrication workshops. I've got a little QR code marker, and then I've got a little Ruko cube here, which is, those 6 Ruko marker faces kind of taped together in a little box. And these markers give us the ability to basically send not only positional data, so maybe like planes tracking our location in physical space, but also like we could create like a custom code that sends that data specifically to Grasshopper using the track markers component. So the one that we're obviously looking at today is a Ruko marker tracking just with a singular plane. We're not going to do the box tracking, and we're not going to worry too much about the QR code one, but just be aware that you can do different types of marker tracking with the Fologram for mobile app, but also in particular for the Fologram for the HoloLens. So we're going to use the Ruko markers to basically augment a physical tool with a holographic fabrication instruction interface. And that physical tool is going to be almost like a dummy version of a carving wand that you would have if you were doing foam carving, to kind of simulate that foam carving that you saw. I think Will gave a little bit of a preview of it in the lecture on day 1. So the track mask component, it works in a very similar way to all of the other tracking components that we've used. So you want to have a connected device component dropped onto your canvas and plugged in, so you can actually, you know, speculate or specify which device you're tracking at any one particular time. And you'll notice that, I might just turn off my profile because that's getting in the way. You'll notice beneath the track markers component, you've got a bit of information. So we know what always means. That means we're always tracking the marker. We could change that to say if it was just when we were holding on our device, or if we were tapping on the device, or if we were when we were dragging on the device. We're going to leave it at always. We also have a little a size specification. So 45 millimeters is the default size. That's actually just measuring the size of these Aruco tracking markers, so we can get an accurate tracking of those markers themselves. So if you printed one off at a much larger scale, for whatever reason, you'd want to adjust that that number as well. And then we can specify what in particular it is that we're actually tracking. Are we tracking an Aruco marker, are we tracking a QR code, or are we tracking an Aruco cube? So one of these 3 trackable items that you see on my screen in my mobile device. So to access these options, we can just right click on the track markers component. We're going to leave our track marker as always at the moment, and I'm just going to turn off QR code. We're not going to track the QR code in this situation. So I'm just going to turn that off, and we're just going to have always on 45 millimeters and Aruco marker. So I'm actually going to remove these extra pieces out of the way for now, and we're going to focus on just tracking this Aruco marker itself. So the first thing I'm going to do is I'm going to go ahead and connect my device to my live session. So I'm going to come to the Fologram tab, and I'm going to just click on connect to device, and I'll get the QR code appear. So I can go up here and just scan that QR code, and then I'm just going to go and place my origin point over here next to my Aruco marker, just like that. I might just put it slightly to the left of the origin now. So we've got a connected device working, which is good. So I hover over here, or I could go and put like a panel on the side here, and I've only got, you know, one mobile device appearing, which is good. But you'll notice I don't have anything coming out of the trackables right now. I just saw a quick question on the chat, so I'll just answer that once again. I'll just give everyone a second as well, just to connect their device up and then just get a track markers component working as well. So, if you've downloaded Chromodoris, you should have this kind of in a zip folder. So grab the KD-tree DLL file and the Chromodoris GHA file and copy them. And then inside of Grasshopper, you want to go to the Special Folders Components folder section, which will look something like this. And then you want to paste them in there. And then you'll just have to restart Rhino and Grasshopper to get them working. But I mean, I might pause the session for 2 minutes later on, and you can restart later, right before we get to the Chromodoris part. So I can prompt you guys when we're going to open that one up, and you can restart Rhino so you don't, lose any time here. So that's how you do it. You just go to File, Special Folders, Components folder, and you should be able to just put them into there. Cool, so despite the fact that we've got a tracked marker on our screen, I'm not actually getting information from my tracked markers component right now, despite the fact I've got it set to always track. And that's because of overheads with the application a little bit. We have to manually specify in our Fologram application to turn on the QR code or the Aruco marker tracking, whichever one we wanted to do. So if we all go up to the top left of the application where we have the little gear, which brings us to the settings tab, we've got a bunch of little toggles that we can click on and off. So I've got shadows on currently, but everything else off. You'll see at the top of those toggles we have an Aruco marker tracking option, and we just want to go ahead and toggle that guy on, and then we should be able to get some data coming into our Grasshopper situation here. So straight away we see from the trackables we're getting a tracked kind of square, which represents that Aruco marker that we have sitting on our desk. And I could go and move this, and you can kind of see live in Rhino how that's kind of updating based on the location. So I am able to go ahead and track that marker live to Rhino and send all of that positional data as a live kind of stream. So obviously if I move it out of the way of the device, you don't see it, but whenever it's in view, it's going to update live the location and position of that marker. Cool. So the other thing I just want to quickly talk about with the trackables or the track markers component is the trackables output from track markers. So I talked about this a little bit yesterday about this kind of dynamic output from Grasshopper that gives us different information as we output. So the trackables output can give us, as we see here, a number. So if I had a number container, we're able to get the number 1 coming out, and this is relative to which Aruco marker number this is. So Aruco markers, if you've seen kind of like this list, you'll notice that they all have little numbers next to them, and this is Aruco marker number 1 in that list. I think it's actually that guy there. You can kind of see lining up with my my sheet over there. So say, for example, if you wanted to use multiple Aruco markers in a tracking simulation, you could keep track of them all through their numbers. So every marker would obviously be unique, and then you could do multiple ones in a simulation all at once. We can also turn this into, I think it's a mesh plane that we output here. So if I've got that mesh plane, it gives me the actual square data coming out of here. But we could also turn it into a point to get the location of the marker. So that gets the kind of bottom left location just here. Or we could turn it into a plane, and we get the transformation data. So if I go and, shift and move this around, suddenly we're able to locate a plane in Grasshopper that follows our Aruco marker in 3D space, which is a really powerful tool. There's a lot of really powerful things that you can and that we'll experiment with today with this plane output. Cool, so I'll just give everyone 2 minutes to have a go at getting that working if you can. Hopefully you've printed it all out. And if you're having any issues, as always, just jump on the chat and let me know. Cool, so I'm not getting too many comments on the chat. I just want to get a check, if a few of you printed off the Aruco markers and you've got the tracking working, it'd be good to get a bit of feedback to see if anyone's able to actually get this kind of live tracking simulation working on their device nice and easily like that. Just give me a little life in the group chat if anyone's able to get there with that one. Cool, so yep, so blah 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 Barbara. In terms of what your one's doing, I'm guessing you're tracking multiple markers at once. So that is why you're getting a list. So it's going to be able to track, like if I had all of these markers visible, it's going to be able to track all of them and go ahead and do that. So as I mentioned at the start of this tutorial, you can get the markers file, and I mentioned yesterday as well, you can get the marker file from this forum post here, Sculpting Geometry with Fologram. It is right there. I've also posted it yesterday, I think, in yesterday's tutorials in interactive rod bending design. They're also there as well. So there's a couple places you can go and download them pretty easily if you haven't got them already. Cool, so a few people look like they've got it working, which is great because I think it's a pretty great and powerful tool. So now we could go and look at how we can actually build a relationship between our device and the tracking component itself. Cool, so the way that we're going to do that, it's really simple kind of thing that we're going to do. I'm actually going to just delete these guys for now and just keep the plane output coming out of here. So we're going to take this plane data basically. And I am going to create a domain box. Box. So this one here, it's like this little box that has kind of like these measuring markers next to it. So just type in domain box. What I could do actually for everyone once again is I could put bifocals on and I can change it to icon mode so you can see the name of the component and then the icon itself. I think that might be a little bit more helpful. So we could go ahead and put a domain box under here, and I might create a slider that's about, I don't know, 50 millimeters. Well, actually we want it to be about approximately the same as the Aruko marker, which we know is 45. So I'm going to make a little box that kind of follows that. So now if I move this marker, the box is going to start following. And then we can obviously, extend this logic even further with Fologram and create a sync object component. I'm going to right click on this and maybe make it a nice kind of deep blue color and attach that guy there. And then you can see on my device straight away what appears is this box that goes ahead and follows the QR code marker on my screen. So whenever it's visible, that box is going ahead and updating, and it's just following on my device like that. So I'd like everyone to just have a quick go at trying to get their marker to have a piece of geometry like this box appearing on top of it, just like that. So Chi, I'm just checking if you said anything else previously. As I mentioned, if you haven't done this already, go into settings on your app and you need to turn Aruko marker tracking on inside the application, okay? So this isn't on by default. I mentioned this before. It's on when you specify it, just because there's overheads that are associated with that inside of the app, and the app would not run as smoothly if you had it on all the time. Cool, so let me know if people were able to attach some stuff to their geometry. Obviously it doesn't need to be a box, so you could attach anything. It's basically orienting to the bottom left corner of this device. That's where our plane is sitting. And of course let me know if you have any issues getting to that point. We'll try and work through them together. Okay, so not much other life out there just yet, so I'll assume everyone's able to get their marker working nicely on their devices and everything's working okay. So obviously that's a pretty interesting tool just for moving some geometry around, but we can actually extend this logic to augment maybe like a physical part of something. So if you had like a drill, for example, you could stick an Aruko marker onto a drill, and then you could display extra information on top of that drill for a fabrication process. If you had, for example, in the foam carving application, like a foam carving wand, you could place an Aruco marker and start displaying, information about the fabrication over the top of your wand as well. So what I've gone and done, and I'll just show you an example of this. I'll get that guy out of the way. I might go and create file, new document, just to refresh that. I've gone and grabbed a little kind of like wand-like thing. It's actually a drill handle, and I've gone and taped an Aruco marker on top of the face of that. And basically I'm going to treat this almost as like a pseudo fabrication wand right now. So if you had anything that you could kind of just quickly augment, like if you have something lying around, I mean, it could just be like a simple, phone charger battery pack. It could be, I don't know, a quick, like a knife or something really simple that you can augment. I highly recommend you maybe kind of try and grab it and quickly drop an Aruco marker on top of it, because we can go ahead and create like an augmented tool from this project. Yeah, Chi, you definitely need to connect the phone to the PC. So obviously we're creating a live connection between our Rhino session and our phone. You definitely need to connect those two. So see how mine's connected there? You won't be able to scan the Aruco markers unless you've got that connection working. Cool, so I'll demonstrate this process because I'm guessing everyone won't have time to quickly set up a tool, and then I'll let you guys potentially try and attach a piece of geometry to any kind of object that you've got lying around, and we can kind of work through that together and show how we'd go about creating like this carving tool within our application. So I'm going to start with the standard connected devices component. Well, I'll drop that bifocals thing up here, just there, and then I'm going to get another track markers component like this, and plug that guy into there, and straight away we should be able to track that plane like there, just like that. In fact, I might just give everyone 5 minutes quickly. If you can just quickly find something and go and place a marker onto the tool or onto anything that you've got around, that would be really great. Because I think it would be really beneficial if everyone could kind of just quickly put it onto something. And so no, maybe I'll demonstrate it again because I feel like you potentially weren't watching what we were doing when I demonstrated that. There's nothing about pressing any buttons on the phone. The only button on the phone that you need on is this Aruco marker tracking. So just make sure that that's turned on there, and then you have a track markers component sitting over here. One issue you might be having is if your origin is nowhere near your phone, say if it's all the way over here, that's where you won't be able to see where your marker is. So maybe just check if the track trackables is coming out with an output. So if you have like a plain output like that, just check if that's appearing, or just check if the mesh is appearing generally. You just want to check basically if there's any data coming out of this thing. So if you see plain information constantly updating, that's good. If you see a number or any kind of data in here, you should be able to track that marker easily. But the first thing you definitely need to do is make sure that you're connected to your Rhino session. So make sure you've got a live connection working, then turn on Aruco marker tracking in your device, and then you should be able to use the device component and then track markers component. So then I'll just give everyone a couple of minutes, maybe we'll give everyone 5 minutes to just go ahead and attach your QR code to almost anything really you could use just for this simulation. Obviously, in a real world scenario, we would be attaching it to like a carving application or something, which would make it a little bit easier to kind of understand the concepts of, but because we don't have the access to a carving tool, we're just going to pretend that we've got the tool in front of us like this, and that we're tracking the location of the tool. Because basically if I go and like pick this tool up now, I'm actually able to kind of get positional data about the tool itself from that Aruco marker. So Chi, were you able to solve that problem? Let me know if you're able to get your marker tracking. Or if anyone else is having issues, just let me know in the chat as well. So good question, Blababara. What you could do, and you won't be able to do like a 3D scan because the camera on your phone isn't capable of getting that kind of data. You could measure things with a Ruco marker, so you could do a really low resolution scan where maybe you like measure from this bottom piece up to, you know, this top piece here with another marker, and then you could draw a line between the two planes, so then you're kind of measuring that location as well. But in terms of physically scanning the object, you can't do a scan of the tool. Even with the HoloLens, what you would get is you'd get a really low resolution kind of blobby mesh. It wouldn't actually look like that tool. My assumption with this is that maybe in about 5 years from now, you'll probably be able to do that. But right now, the 3D scanning information that's built into these devices can't get you the resolution, especially not with an object like this one. Like this object's pretty small. You'd need a proper 3D scanner to get a good scan of that tool. So the track scan, whilst it does your environment, in the HoloLens you can actually get a slightly higher resolution version, definitely not with your mobile phone. All right, so I think hopefully that's given you enough time to just quickly attach the Ruco marker to you know, some kind of quick makeshift tool like my tool here. So the next step would be trying to create some kind of like holographic information that we overlay on this tool. So we're going to basically create a sculpting tool out of this, or a pretend sculpting tool, as the kind of end game for today's session. And the way that we're going to do that is we're basically going to use the end of this tool that I've got here. So up here, it's basically the location where we're carving or sculpting out using the Chromodoris plugin later. So I'm going to try and just basically create something really simple at the end of this tool that's going to feed back information about my sculpting process. And the simple thing that I'm going to add is going to be a mesh sphere. So I'll just drop a mesh sphere into the canvas so we can have a quick look at that. And we could actually just go ahead and, you know, put that onto our device just for now. So, you know, we've got a mesh sphere that's following our device or our tool location straight away. But what I want this mesh sphere to do is I don't want it to appear down here at the bottom left. I want it to appear here at the top, at the end of my tool, basically. So we're going to basically use the information that we've got from this Ruco marker to move our sphere to the end of this tool, so it always stays in that location when we move the tool itself. Sorry, I'm just reading one of the comments. Yeah, so I could potentially show an example at the end as well, where we were trying to recreate parts of the steampunk timber pavilion to give you guys an idea of this low resolution scanning techniques. Maybe I'll show that at the end actually to give you guys an idea of how that might work as well, and that might be quite interesting to you as well. I think your name's Barbara, but it's an interesting YouTube name. Cool, so like I said, aim of the game here is to move this sphere so it sits at the end of this tool up here. So to do that, I'm actually going to use this plane. I'm going to come to the Vector tab, and under Plane, I'm going to grab the Deconstruct Plane component, and I'm going to drop that onto the canvas. And we're basically going to get some information about this plane in here. So the information we're getting is the location of the plane, we're getting the vector direction of the x-axis, which would be the axis in that direction, we're getting the vector information of the y-axis, which would be the axis in that direction, and we can kind of like zoom in and have a look at this more closely. So that's our x-axis there, that's our y-axis there, and then we also have the z-axis, which would be pointing kind of like outwards away from the tool itself. So those are really important little pieces of information that we're getting from this Aruco marker tracking that's attached to our tool there. So now what I'm going to do is I'm going to use these vectors to basically move this initial kind of location, or this plane that we've got. And we're going to try and move this location from here all the way up to the top here. So to do that, I'm going to create a, in fact, let's just do it from the Vector tab. We're going to go Vector, and we're going to go to Amplitude. And I'm going to create 3 vector amplitude components. I'm going to hold down Alt to copy, like that. And I'm going to have 1 amplitude for the x-axis, 1 for the y-axis, and 1 for the z-axis. Basically, these vectors currently are outputting vectors with a length of 1. So that's 1 millimeter. So if I were to move this sphere up by these vectors right now, they would only move up 1 value. The amplitude component is going to allow us to move it up by a customized value that we specify ourselves. So we could go ahead now and create maybe like a number slider. I'm going to make it about 250 millimeters. But we probably don't need decimals really. I think my tool's about 225 centimeters, 250 mils in height. So straight away we could go ahead and maybe plug that into the y-axis, which is this guy here. And maybe I'll call this y-axis movement. Or maybe I'll just call it y-vector so it's a bit shorter, like that. We could have one for the z-vector as well. The z-vector is going to be a little bit smaller, like probably a lot smaller actually. And then the x-vector as well, that'll be a pretty small output itself. So I'll just give myself a bit of space to put that x-vector. So basically the x-vector is that vector there. So we're just going to move that sphere across a little bit into the middle. That'll be a small amount. So we could go ahead and move this trackable's plane, or the trackable's output, along a vector axis of whatever that is. So that's way too far straight away. I want to try and get that towards like the middle. So about there. And then we could update, you know, this mesh sphere's base input like that, and our sphere will kind of update like that. Cool. I might actually make a new slider for this because that's just way too big a range. I'll go and call that one X vector. And then we just want to get that one about in the middle. Then for the y vector, we're going to move again. So we'll move that geometry by this much. And I'll plug that geometry into there. So creating like a bit of a chain of movements. So that's pretty close to where I want it to. It suddenly looks a little bit out of axis on the x vector actually. And then maybe if you wanted to, we could go and move it up a little bit higher on the y. Something like that. And then the Z one will move, but I won't do much about it right away because it's a little bit hard to tell from the angle on my phone. So we'll create another move. We're going to move that geometry by the Z vector here. I'm going to make it, I'm actually going to delete that one and make it smaller as well because it's going to be a very small movement, that one. and I'll just call that Z vector, like that. So we're just creating this little chain of movements for this mesh sphere. So I might preview those guys off as well. And then in our device, we're getting that appearing there. I'm just going to remove that vector axis here, actually. So you see it kind of moves away from the device like that, or from the tool. So now we could go and just inspect where that kind of ball is. So it actually looks like it probably wants to move slightly in the negative direction for the z-axis to me with my tool, because I'm just trying to get it to align to kind of like the top and center. So maybe I'll create a little negative component here, like that. And we'll just move it ever so slightly in the negative direction. So basically now what we're doing is we're just aligning our mesh sphere to our tool itself. And we could actually do this in a bit more of an interactive way. I could go ahead on the Fologram application and synchronize the parameters here. So I could send the X, Y, and Z vectors to my phone and just very kind of like slowly move that guy backwards. Like that. Cool. So now when I go and pick up my tool, I'll have this sphere sitting at the end of the tool itself, and it's going to follow it as we kind of move around like that. Cool. So whenever you're aligning data or trying to overlay data on top of a tool, it's important to try and create these kind of little sliders that give you that kind of easy to change accuracy, because there's no guarantee that you've aligned your marker in the right spot. So you want to have that manual control over the location of some of these overlays. And you can do much more sophisticated overlays than a sphere, obviously. You could start doing, you know, different types of geometry or things that you want to overlay over a specific tool. If you want to augment an end effector for a specific tool, you might have a more complex augmentation process, but the logic's still the same. You're basically just applying a piece of geometry over a transformed plane that's coming from the Aruco marker session. So I want everyone to have a quick play around with that little workflow and try and augment the tool that you guys have quickly created. I might make my radius a little bit bigger. I make it a 30, I think, just to make a little bit of a bigger thing. It's a bit comically large now though, but something like that would be good for the tool that we're about to build, because basically this sphere is going to serve as a little bit of like a it's going to give us feedback in the fabrication process that we're about to set up. So we might take a quick 5-minute break whilst you have a quick play around with that. The other thing I'd love you to do, just in time for when we come back to the break, is just go and open up that that file, the sculpting template file that I asked you all to download, and just check that you've got Chromodoris working. If Chromodoris is working nicely, you'll get a pink sphere that looks like this, and a little rabbit that sits inside of that that kind of, oh sorry, a pink box I should say, and a rabbit that sits inside of that box. So go ahead and try and get that augmented tool working, and then once, in 5 minutes, we'll all jump back on and we're going to apply the logic onto this, this tool here. Also, if you've got any questions or you're having any issues, feel free to jump on the chat, obviously. Or if you've got an idea for a project where you'd want to augment another tool, or you're interested in like different types of scanning techniques as well, like we're getting questions in the chat about, happy to kind of have a chat about that as well. So just let me know in the chat. The last thing I should say, if you've kind of got it all working nicely, you could actually just quickly have a play around with what this tool currently does. So I've already set it up to do something inside of Fologram. If you press and hold on the device, you're actually given a sphere straight away, and you should be able to go and carve out some geometry in the simulation. It'll be a little bit slow because, or it might be a little bit slower than you'd think, just because there's a lot of points that Chromodoris is kind of calculating, but it should be almost real time as you kind of go through it. And you should be able to start kind of like getting a feel for how this is going to work as a carving application, just like that. So I'm getting feedback saying someone's installed Chromodoris, but they're not getting the pink box. When you go to the end of the definition, do you have all of this geometry sitting over here nicely? Do you have any errors when you open the file? It'd be good to get a bit of feedback as to why you're not getting the box, because it probably sounds like the application hasn't installed correctly. Maybe just check that you've got Chromodoris installed up here as well. That would be good. Make sure you check your units. I'm working in millimeters. Those could all be factors as to why it's not appearing straight away. You could be miles away from your origin and you're not seeing a pink box. That's another situation that could be coming up as well. So just check those few things and let me know if that solves any of those issues. Okay, so you're saying that your sample voxels is red. That's a little bit weird. Can anyone else let me know if they're having similar issues, or if has anyone actually just got it and it's working? Has anyone tried the app? It'd be good to just hear if anyone else is having a similar problem. What points do I have coming out of here? What's the error say? It'd be interesting to hear what the sample voxels red error says. Cool, we've got one saying it's definitely pink and definitely working. That's good. So if it is working, like I said, just grab your device and try and have a quick carve and see how that kind of feels, just with like a little bit of a manual carving of the voxels. So that sphere should go ahead and start carving geometry out of your little kind of pink box. Cool. What I might do first is I might just give you guys a quick rundown of what the algorithm itself is actually doing, so that you guys can kind of get a feel for what it is. Basically, the way that Chromodoris works, what it is it's an isosurfacing plugin, and isosurfaces are kind of, I'd almost think of them as 3D contours. So everyone probably knows what a contour is. When you have a geometry, you kind of slice it up with kind of different slices. Almost imagine if you were like in a room and it had like a certain temperature. and you would have basically, maybe the temperatures ranged from 0 degrees Celsius to 30 degrees Celsius. You would be able to draw a line through the surface, like a contour, that specifies where it's 20 degrees Celsius. But because the room itself is 3D, you could easily draw an actual volume that encapsulates all of the parts that are 20 degrees Celsius. So it's like kind of like a threshold. And that's basically what isosurfacing does. It creates these kind of blob-like forms in their most common form that basically cut through a certain space based on a value, almost like it's a temperature value or something. So then you kind of get this shape that gets kind of carved out. So what Chromodoris does is it samples basically a bunch of points. So what we're actually doing here is we're just creating a little box that becomes an array of points. And all of these points are being sent over to Chromodoris over here. And then inside of Chromodoris, it's basically giving each of these points a value and then cutting through a kind of blob-like surface at those values. So what our algorithm's actually doing is we're going through and we're cutting out some of these points. So we're just removing these points from that initial list. So you see here, that one to that one. We're just removing all those points, which means that the kind of carved output or the carved surface it becomes like smaller and like more compressed. So basically what we're able to do then is almost use this as a pretend foam carving exercise where we can go ahead and carve out some of this geometry into, say, the shape of a little bunny, like this guy here. So we're never going to get it super accurate because of the resolution that we're working at in Chromodoris is actually quite high, so you're getting a little bit of a jagged mesh faces a lot of the time, but it kind of gives you an interesting demonstration as to how the foam carving application might work. If you guys are getting that red arrow, it'd be good to hear what the red arrow says. I'm not sure if I can problem solve it straight away. But like I said before, the things that I would try is make sure that you're working in the correct units. That's the first thing that I just want you guys to check, because that can have a bit of an impact sometimes as well. I think it should be okay though. Just check that, like, if you preview on the color index, that you've got all of these points coming through, and then it'd be just good to hear what the error is as well inside of that little component, because it sounds like a few people have it working. So maybe it must be something very specific to your session. I'm not entirely sure what it could be. For those of you who have it working though, what I'd like you to do is come over to this little green area of the application, and we're going to just delete that. So that's the thing that's actually kind of helping us carve right now with the sphere, so with our kind of like tracking cursor. It's basically the same algorithm we built yesterday, where connecting your device, finding the track pointers, then creating a cursor, and then having a little sphere appear at the end of that cursor so we have some kind of depth. I just want everyone to go and delete that basically right now. And then we're going to jump back into the application that we just created with our augmented tool, and I'm going to go and copy all of this. I might not copy the pendant, the sync parameters pendant, copy everything else, and just paste that into our sculpting file, and then just move it over here for now. Okay? So a few people are getting that error. I'm guessing it actually might be a computer issue or something. It could be if you're using a really old laptop as well, that might be causing what the issue is. You could try changing the, what could we change actually? We could change the box array to a much lower value. Maybe you could change it to like 5 just to kind of test if it's going to work. Do I get an error when that happens? Yeah, I do, because I'm culling my whole list. But if you change that to like 5, what do you get then? Indices, a list. Okay, maybe what it is actually, it could just be, go and delete that green part I said, and then just set 1 point at the origin, and that might actually solve the problem. I'm going to change that back to 30, just like that. So just delete, I'll just start that again, delete that green section and go and set one point at 0, like that. And see if that solves your issue, just like that. It might do, I'm not entirely sure, otherwise it could be a slightly different problem. But it's a strange one because a few people are getting different issues. The other thing that you could have tried is maybe just drawing on your screen. I think it could also be to do with the point, like it could be to do with this component bugging out a little bit when it doesn't have data coming into it. Cool, so like I said, go and paste in your tracked tool kind of situation that we have going on there. So I've aligned that nicely to our tool, which is good. Oh, okay, there we go. Someone's figured it out for me, which is good. I thought I was quite clear with this. Make sure you have copied this DLL file. I think I said it 3 times at the start of the tutorial, but obviously that wasn't enough. KD tree DLL, make sure that's copied into your libraries. And then properties, make sure it's unblocked, really important. So when you download that Chromodoris plugin, it comes with those 2 files, which was the 2 that I was asking everyone to download. So please make sure you've got the KD tree DLL file in your libraries folder, otherwise it's not going to work. Sorry, I just assumed everyone had done that. Cool, so thanks for resolving that one. Ran you one. I appreciate your detective work there. I'm guessing that the error that I was asking everyone to post said, you know, you don't have the KD tree thing. So really important that you have that in the tool set. Cool, so we've got this kind of track geometry. It should still be working, I think. Yep, we've got our sphere tracking there nicely. Cool, like that. And what we're going to do is we're basically going to substitute out that old cursor tool for this, what are we calling it? I don't want to call it a tool again, but I guess it is a tool. We're substituting out the cursor tool that we just had for a physical augmented tool, let's say it like that. So I'm actually just going to drag these 2 mesh sphere and sync object components down here, and I'm going to plug in this move geometry into the point input over here, like that. So now basically if I grab my phone and my tool, I should be able to go up to my carving application and hopefully do some carving. So it'll be a little bit harder than it was to do with the pressing down one, but if we were wearing the HoloLens and we were doing this with a actual foam carving tool, this would work really nicely for us because we'd be able to easily go up with our augmented tool and carve out the foam, and we wouldn't get this kind of like overlay that we're getting right now. So I can go ahead and you can kind of see on my screen, I might just make that visible in Rhino as well, so everyone can kind of see. Give me 1 second. So I've got over here you'll see my kind of like my tool slowly move across. So I've got it there and I'm able to go in and kind of start carving out with that tool like that. Cool, so I'll give everyone 5 minutes just to get to that point and just try and get that carving simulation working. And let me know in the chat if you've got any other issues as well. So if your tool's not carving, you probably just need to get a little bit closer. So if you have plugged in this point into the closest point output and it's been moved properly, it might just be a little bit of a depth perception thing, which will become a little bit of an issue just because of the way that we're simulating it. Obviously, if we were doing this in an actual fabrication scenario and we had a big block of foam, we wouldn't have an augmented foam on top of it as well, getting in the way of where we see our tool is. So as you can kind of see right now, I'm putting my tool over here, and I kind of need to carefully just look where my sphere is, and the tool itself is being distorted a little bit because of that process. So because we don't quite have kind of like the tool itself in the way that we'd like, we have to kind of make do with it. One thing that you could do, I mean, I can try and do this on the fly, just as a little demo, is we could try and create an occlusion, what's called an occlusion geometry that will actually make our tool invisible, and it gives you a little bit better depth perception. So you don't have to necessarily follow on with this, but I'll just kind of demonstrate it really quickly. Coming out of trackables, maybe we could like make a box, maybe another domain box, potentially like that. Would that be the best way to do it? I guess we'll find out in a second. So there's my tool, and we know that our tool's somewhere around here, so I'll just quickly make a box. Maybe it's like, we'll make it 45 just to get an understanding of where those dimensions are. So I want to make it -45 in the Z direction, probably, just approximately, I'm kind of saying. Then we want to have like a bit of a higher value for the X. No, that's actually quite good, isn't it? 45 is good. And then maybe for the Y, I think, what did I say? It was like 250 or something in height. And I'll just see if this is going to work. So I haven't really tested this workflow much, but if we created a sync object component and we set occlusion, sits down here in the application on, it should disappear, but I think we get, hopefully, yeah, we get a little bit more feedback to where our tool is. So obviously if I had like a proper model of my tool, I could occlude over that geometry, and that would give me better feedback from the tool itself. So what the occlusion's doing is it's basically creating this kind of like invisible tool that makes other geometries behind it appear behind. So because we know that my tool's in front of that hologram, we're basically occluding that geometry behind it. So you could use like an occlusion tool to give yourself a little bit better depth perception if you wanted to. So that's all I've done there, is I've just created like a little box that kind of represents what my tool is. But you could model your tool up one-to-one. It'd be great if it was a 3D print, because then you'd actually have the accurate file and you'd be able to augment it really accurately. But that could be one way that you could give yourself better depth perception. So that, once again, if you right-clicked on the sync object component, you could go and occlude the object itself if you wanted to test that out. Cool. So one kind of issue with this process right now is that we don't really have a lot of feedback from the workflow. So the workflow kind of relies on a really accurate movement through 3D space with our hands and our tool, and this is a lot easier in the HoloLens. Obviously with a mobile application, we're just trying to simulate the workflow, and we're not going to get the same level of accuracy potentially in a mobile workflow, but we still will have kind of like a weird depth perception even when we have the HoloLens for these 3D sculpting techniques, because we can't quite see where we're carving, because our tool would be like inside of the carving situation. So what we can do to kind of help ourselves out and to mitigate this so we're not creating these inaccurate kind of carving techniques, we could go ahead and create or amend our algorithm so that the sphere at the end of our tool could turn maybe a different color when we got super close to our bunny geometry. So basically, we're going to try and write a little algorithm for that. So we're basically going to say whenever this sphere gets close to the bunny, it turns a different color. So we know to stop carving because we want to carve out the bunny and we don't want to make a mistake of going too far and carving into it. Obviously, with a subtractive process, that would be a little bit catastrophic because you can't really undo that with that kind of process. So I'm going to come over here where we've got the mesh object of our bunny that's been synchronized on this side of the canvas here, and we're going to do a little bit of an operation on this. We're going to use a couple of new components that we haven't touched yet in Fologram, and I'll kind of describe what they are in a little bit of detail in a second. But basically we just want to move this mesh sphere that we're previewing over here near this kind of bunny mesh that we've got going on here, because these two things are going to work in tandem. So to do this, we basically want to build a relationship between the mesh and the location of our mesh sphere. So I'm going to do a mesh closest point component, which is that guy there. And we're basically going to measure this point, or the plane, which can transfer over to a point, to this mesh. We're going to basically say, okay, here is the point of our geometry, which is actually this guy up here. There he is. Where's his closest point on the mesh? And currently it's sitting right there on the mesh, which is good. So we've formed that relationship between our mesh and our marker. So what we also want to do is we want to measure the distance between those 2 points. So I'm going to go from this this geometry here, so this moved geometry here, to that new closest point that we've found over here, and we're going to measure that distance, and it's, you know, a certain value in length. And we're going to basically create some color values that basically relate to this distance rule. So I'm going to go to display up here in the Grasshopper Components tab, and under color I'm just going to select color RGB, and we're going to very manually give some color values out that relate to this relationship of the mesh closest point. Basically what we want to say is that if we're further away, we're one color that we know about, and then if we're too close, we're, say, maybe a red color. So we turn red as soon as we get really, really close to something. So this distance when you're further away is a really, really high value, and basically when you're really, really close, it'll be a low value. So what that means is that to get a red output when we're really close, we want to plug in this distance value basically to the green or the blue, because if we're really close to something and you remove all the green and the blues, then you're going to be left with a red color. But to make sure we have a high red value, we just need to manually specify that. So I'm going to create a little panel, and the highest red value in RGB is 255. I'm going to plug that into red, and we're going to get a color that will basically be a red color straight away. Like that. So then we also want to specify, say, maybe the green color. And we could just go and plug the distance into there, but because the distance is like such a large value, we don't want to just put in, 1400 on the green. We want to cap that at 255. So I'm going to create a component called the minimum component, which you might have used before if you've used Grasshopper a bit. And it basically lets us put in a couple of values, and it's going to select the lower of those two values. So the first value I'm going to put in is this 255 value, and then I'm going to put this distance value in as the second one. So basically if we're really, really far away, so in this instance we're 1.4 meters away from our bunny, it's going to pick the smaller value of those two, which in this case is 255, and then we can transfer that into our color kit. If we get really close, say if our distance was 10, it will pick 10 because 10 is smaller than 255, which will reduce all of, say, the green values and give us a redder color. So basically if I go and plug that guy in now, the color value will be less red, and as we move closer to as we move closer to the object itself, oh, sorry, I'll just reset my simulation. Then as we move closer to the object, you'll see on my screen, you won't see it on the sphere just yet, but if we get super close, you'll see that middle G value starts to drop when I get really close to the bunny like that. So that tells us that relationship is kind of working nicely. So the big question that we have now is, how do we go ahead and apply this color to the sync object component? So previously, when we've been applying material, so I'll just make this bigger so everyone can see exactly what I've done. Obviously I'm connecting from that move. Obviously, when we've been applying materials previously, we've been right-clicking on the sync object component, and we've been changing these kind of slider values in here, and that's going to go and update our geometry color. But we don't have an input to plug in some material values. So what we need to do instead is we need to use a couple of extra components in the Fologram library to override this material to build a parametric material relationship. So the components that we want to use is we want to use the assign material component, and this assign material component will basically just take any synchronized object as the first input. We see synchronized geometry there. And then it will also take in a synchronized material, and this will enable us to build a a parametric material that responds in real time. So firstly, we need to actually just create a material. So I'm just going to type in material. So create material there. And the diffuse is the only input we care about here. That's just going to be the color of our material. We could add different kind of material effects if we want, but we're just looking for something really simple because it's just a basic fabrication task. So I'm going to go and plug the diffuse into there, and then we've created a material, and now we just need to create a synchronized material. So under the sync tab, we've got a sync material component, just like that, and we could plug material into that guy, and then plug that synchronized material into this geometry. So now when we look at this this sphere, let's say, well, hopefully it's working. Something's gone a little bit wrong there, and we get closer. Just give me a second. I might need to just reset that sync object. Actually, it looks like it's just having a little bit of an issue. 1 second. I think the copying of this sync object's caused it to bug out a bit. So I'm just going to create a new sync object, sorry, like that, and hopefully that overrides the material. There we go. So there's just a little error coming up that was caused by a little bit of a bug. So now we see that we've got this kind of slightly yellow end piece on our tool. And if I go and grab this tool now and I move closer to the bunny, you'll see as I get closer and closer, it starts to turn red. So when I get to red, as you can see, I've accidentally gone and carved out, I'll just get that tool out of the way, I've gone and carved into the bunny. So I've kind of made a mistake there. So suddenly we've got a tool with some material feedback based on our tracking simulation. So you see how it gets slightly darker as we kind of move in. So then you could use this tool to easily go in and carve with some feedback as to the current location of the end of that carving piece. And then we're essentially able to use these assign material and sync material components to override this this sync object component here. So we're no longer using the materials coming out of that guy. Cool, so hopefully that made a bit of sense. I'll give everyone a few minutes to try and have a play around with that, and let me know if you're able to get that parametric relationship between the colors of the end of the sphere on your tool and the distance to the mesh itself. So one thing that I kind of noticed, I think it's a little Fologram bug that I just need to take note of, is that when we copied from this old file, this sync object didn't get overridden by this assigned material. So just delete that sync object component out and swap it with a new one like that for now. And then let me know in the chat if you're able to do it. I'd love to hear if there are a few people who are successful. Let me know in the chat if you're having issues, and we can try and work through them. So if you've got a problem, tell me specifically what's happening, and I'll try and give you guys a hand resolving it. And let's then we'll get back to it in 5 minutes once everyone's had kind of a play around with the tool. All right. Anyone in the group chat, was anyone able to get that one working okay? It can be a little bit of a tricky one because we're obviously building a relationship between something that's moving and then trying to give some feedback, but hopefully it's like an interesting explanation as to how you might go ahead and kind of like create or augment a tool and give live feedback whilst you're using that tool, which is kind of like the exact thing you need for this kind of carving exercise, but it could certainly be transferred over to different types of other fabrication workflows that you might work on in different scenarios. So it'd be good if anyone's having issues, let me know, or if anyone's able to do it, let me know as well, or if you've got any questions about the workflow or other workflows, that'd be good. One other thing I might touch on is the one that one of our users in the group chat's talking about or asking about, which is scanning techniques. So obviously with scanning techniques, you're not able to do high resolution scans with your phone and not necessarily really able to do high resolution scans with the HoloLens, but with Aruco markers we can certainly do low resolution scanning of our surroundings. And I might just quickly show you guys one workflow on that in a couple of minutes. I'll just give everyone 2 more minutes to have a quick play around with this tool, so let me know if you're having any issues, and then in 2 minutes I'll demonstrate one last quick kind of fabrication Aruco marker tracking workflow that you might find useful. That's actually to do with the Steampunk Pavilion project. Cool, so I might just quickly showcase what this tool kind of was used for from our perspective when we were doing it, but you could definitely apply the tool to different types of fabrication workflows. We've certainly used it on some of the steel rod bent pavilion projects we've done before, and we've used it for other kind of like low resolution 3D scanning workflows. But this is a little clip from when we were working on the steampunk pavilion. Basically, when we were bending the steam bent timber and then assembling it on site with all of our steel pieces, we had a little bit of an issue where some pieces weren't accurate to our 3D model. So some of our pieces of steel weren't actually fitting. So we were using Aruco markers essentially to draw a kind of lofted surface of each of the timber pieces. So we'd basically go and create a low resolution scan of these timber strips all the way up, and you do like 5 or 6 of them, and then our engineer would say, well, you need a steel bracket in this position. So with this digitized version of these strips, we were able to go and design new brackets that fit the structure perfectly, despite the fact the structure was slightly different to our design process, because we had some spring back that we weren't expecting from the steam bending process, or maybe something had been installed slightly incorrectly on site. So you can kind of see just with the tap, gesture on the HoloLens, this is me doing the scanning and GWIL filming. We're able to go and create like this really kind of low resolution version, but still has all the information that we need to go and do the process. So we're able to easily kind of recreate these physical objects and send the data to a digital platform in Rhino. So I want to quickly just talk through the workflow for that one as well for you guys just quickly, because there was a little bit of a question that related to it before. And then after that, we'll all jump onto Zoom together, and I'll send through a Zoom link as well. So the workflow itself is pretty difficult. I'm going to go and create a file new Grasshopper document, and I'm going to use the connected devices component here. And basically, I'm going to once again get a track markers component in there, just like we're doing before. I'm going to right click, and I'm going to make it only Aruco marker checked. So just uncheck the QR code markers input as well. And then we're going to grab the plane data out of these trackables. So we're going to transfer into planes. We're not really worried about it being like a mesh or a point geometry in this scenario. We're going to use some global variables as well. So I'm going to drop some global variables onto the canvas. I'm not going to bother renaming them because we're not going to actually use multiple. So we're okay with just leaving it as called global. But I'm basically going to do the typical little merge workflow that we did yesterday, where we're merging in those globals to try and like save out a new global variable each time we do a tracking situation. Oh, one last thing that I should mention we want to do, right click on this actually and make it on press. So we're actually only going to track on the pressing of the device. We don't want every single marker track. So make sure, really important, that you select on press for this scenario here. I'm going to then have this global variable over here to re-input on this side. So all of those kind of planes that we're going to save out every time we press on the trackables component, I'm going to go and deconstruct the plane and get the data we were getting out previously. I'll just drop that bifocals thing on again so everyone can see the names. Then we're going to create a SDL line SDL. It's going to have a start point. It's going to have a direction, which is going to be from the y-axis, and then we're going to have a length, which is going to be, depends on the width of what your timber board is. Let's maybe say it's a width of, I don't know, 80. So that's 80 millimeters because I'm working in millimeters. Then we're just going to loft all of those lines together, like that. I might actually flatten coming out of that merge as well, just in case we get some weird data structure problems. And then I'm going to go and synchronize that object. So we built a really simple definition with all of the components that we've been looking at so far in the workshop that actually gives us power over some really simple kind of tracking. So say, for example, if we had, you know, the timber strip somewhere, we could easily go with our marker and we could kind of press once on our device. Oops, did that work? Yep, so it presses once, saves that location. I could press again. And let's see if it's working for us. No, one thing I forgot to do, just do this, is you want to have a dynamic update in that global variable to work for you. So then I'm guessing the third time I press it, we're going to start getting some lines appearing, which look good. What's the issue I'm having? I did something at the start that didn't quite work, I think. So I might just go ahead and reset that whole thing, to be honest. So I might just get a global, whoops, that was weird. I'll get a global and I'm just going to get a little geometry container like we did the other day and reset that global to nothing. Then hopefully this time I press once and that tracks my component. And then you see we're able to kind of like create a loft through these geometries. Well, it's struggling to track there. So I'm getting a bit of a loft error. Maybe one thing we need to do is, there's probably a few origin points that are accidentally scanning twice, I think, with that process. So maybe what I'll do is, I'll just make it on release, see if that makes it a little bit better. And we'll reset that guy and update that. So it's not quite working for me. One thing I might do then is I might just quickly cull the duplicate points like that, and I might give myself a bit of room because what's happening there is it's just registering a couple of duplicates with my press. So the indices that I want to do is I want to leave one. And then I basically want to just do a little cull index component like that and cull out those indices, and then we should get a nice list of points that works. So we'll try that again. No, it's not liking my loft for some reason, or is that not updating the global? I'm not sure what's going on there. Wait, no, what it's doing is it looks like it's tracking two planes, so that actually might be a bit of a problem with my data output. I'm not sure why that is. So it's, that's what it's doing. It's tracking my initial old plane, whereas this one here, and it's trying to do two at once. So I might just quickly reset the app actually, just for that one, and it should work better once we've done that. So obviously if I'm sending two planes through in kind of wild positions, it's going to have an issue with the lofting. So hopefully this one works a little bit better. Might not actually need that duplicate. Let's try it again. Is that not working? Oh yeah, hang on, sorry. Ruko marker tracking on, let's try one last time. There we go. And you're able to kind of like create these digitized strips based on wherever you're putting your Ruko marker, like that. So if you had like a piece of curved geometry or something, you could easily go ahead and like create a digitized copy of that with that kind of simple setup. I'll just get that back up because it wasn't that cull problem like that. So over here we're just saving planes, and then here we're creating the strips. Cool, so I might just let everyone quickly set that one up as well and let me know in the chat if anyone has any issues with the setup. And then after that, we'll all jump onto Zoom together and have a chat about some of the things that have been uploaded into the at.studio window, and we'll let you guys present a few of your kind of fabrication ideas. Cool, so just holler out if you've got any issues in the group. So I'll just post the Zoom link in the chat window for everyone to kind of go and join. So that'll be the Zoom link we'll use for this little presentation that we'll do. So I think Will's waiting in there now. But if you've got any quick questions on the chat, just hop on now and let me know. If you've got any other questions potentially about the carving application or any of the other applications, or if you want to see any kind of demonstrations quickly on other things, now's the time to ask. So just let me know if you have any other kind of like concerns or questions that are going on with the fabrication workflows. Alright, cool. It doesn't look like anyone has too many pressing issues, so let's all jump onto the Zoom chat. So I'm going to end this stream now, so thanks all for joining onto this session to learn a little bit about the carving workflow. Hopefully it's given you a little bit of an insight as to how you might go and do that in an actual physical environment, so you could go and easily augment your own tool and carve out any kind of geometry. So you could obviously swap out this bunny geometry with something else and give Fologram a try with kind of like a manual augmented carving exercise. Cool, so thanks everyone. I'll see you in a couple of minutes on the Zoom call.